So, good evening, everyone. Welcome to the I think the third in the series of talks we organized in on the occasion of National Technology Day. We started with a talk by Dr. Somnath, who is the director of Vikram Sarabhai Space Center on May 11th, and followed by an industrialist who was talking about various technological developments, what has happened in the past as well as in future too, orienting towards what will happen in future. Now, today we have a special person from IIT Madras, Professor Sujatha Sreenivasan. I'm sure that all of you might be aware of the standing wheelchair which was developed at IIT Madras, and Sujatha happened to lead that team, and she is talking about technology for independence, basically functional and affordable assistive developments, assistive devices. So which will be very interesting, and I'm pretty sure that I don't want to take much of a time. So I will request Dr. Sharin to introduce the speaker, then we can directly start the talk. Thank you.
Thank you.
Thank you, sir. Professor Sujatha Sreenivasan is a professor from the Department of Mechanical Engineering, IIT Madras. She works in the areas of prosthetics and orthotics and biomechanics and mechanisms. She founded the Rehabilitation Research and Device Development R2D2 group at the IIT Madras, which focuses on the development of assistive devices and aids for the rehabilitation that are biomechanically and economically suited to the Indian lifestyles and conditions. She is a holder of several patents for prosthetic designs. And apart from developing devices, her R2D2 team also does awareness programs in collaboration with various other organizations. We are very fortunate to have her with us today. And now over to you, madam.
Thank you, Sharon. It is my pleasure to be here today on the occasion of National Technology Day. Thank you for your kind invitation to be a part of this series. So, as Sharon mentioned, I head the TTK Center for Rehabilitation Research and Device Development, R2D2 for short, in the Department of Mechanical Engineering at IIT Madras. And our area of research focus is developing functional and affordable assistive devices. And I would like to share some of the work that we have done with you today. So if you look at the broad case of biomedical devices, the primary aim of those devices is to improve healthcare in some manner. And you're essentially applying engineering to either compensate for some breakdown in the human body. So that's where you have joint replacements, you have supports, etc. And you also have assistive devices. So if you see here, I have the spectacles. Most of us don't think of the glasses that we wear as assistive devices, but that's essentially what they are. And glasses are one type of assistive device, and I will speak about some more today in my talk that we work on at R2D2. The other class of biomedical devices are, in the area of robotic surgery, because they enhance the capabilities of humans to do certain things. Exoskeletons, which the army would like to use, in many countries, they're being developed for both for rehabilitation as well as for augmentation purposes by, say, armies and, for in the military, for them to be able to carry loads over long distances, etc. And of course, all kinds of diagnostic devices, which essentially enable you to see inside the body. Those are also biomedical devices. I will be focusing on assistive devices, which are either, some kind of supportive device, like a knee orthosis, or they could be some kind of a prosthesis, which is a replacement device for someone who has had an amputation, or of course, mobility devices like wheelchairs. Those are typically called assistive devices, and I will be focusing on those. At R2D2, our main motivation is to work on problems related to movement disability. Because just for locomotor disability, there are over 30 million people in India alone who are affected. And even globally, the availability of assistive device, the accessibility of it is very poor. Only 1 in 10 people, the World Health Organization estimates that only 1 in 10 people have access to the products that they need. So only 10% of people with disability have the right, have access to the products that they need. And for locomotor disability, there could be various causes. But we primarily work on orthotic devices, prosthetic devices, which are replacement limbs, and we also work on mobility devices like wheelchairs. So if you look at the assistive devices landscape, on the one end of the spectrum, you have very low-cost devices, but most of them are very primitive technology. And this is the type of technology that most people in India have access to. And in many cases, they don't really do the job, and they may either end up, harming the person more because, the device does not fit them properly, so it can cause more problems. Or many people reject these devices because they don't work very well, because they don't really enhance the quality of life for the person using it. At the other end of the spectrum, you have very high-tech devices, but they're also extremely expensive. In many cases, many of these devices, they have not even been translated from the lab to the market. And even if they are available, very few people can actually afford them. Even if somebody in India is able to afford them, maintaining them is going to be a whole other story. And they may not even be suitable for the kind of terrain that we encounter and for the, for the lifestyle that we lead. So there is a huge gap in between, and that is the challenge that we try to address. How can we design more functional devices and yet keep them affordable? That is the problem that we try to address at R2D2. And this is sort of a general framework that we try to use. Addressing the need is very important. So we interface with a lot of users to identify the need. We want to work on problems for, that people actually have, not what we think that are problems. And from those, we try to distill the design requirements. And then we do rigorous research, that could be looking at existing literature, existing design patterns, etc. Because we want to design from the ground up in most cases. We look at various concepts. We do a lot of synthesis, analysis, simulations, prototyping, mechanical testing, user trials, and it's a very iterative process. So we have to go through this multiple times before we can converge on a design that could potentially either, the outcome of it is either a pre-commercial prototype that we could then transfer to somebody. And then, we have to test those to standards and then commercialize it. Because ultimately, impact is going to happen only when we translate devices to the market. Without that, it's just going to be, multiple devices in the lab, but nothing much, and some patents and publications, but not really the true impact that we are looking for. And so that is, we try to follow this framework in our work. One of the things that we do, because of this necessity to translate to the market, we work on a collaboration model called what we call the grid model. And this is a model that we think helps would help us to keep things affordable. So in this model has 4 pillars. G stands for grant. So as an academic institution, we can access grants through the government, through private CSR, through foundations, where the goal for them is to actually create social impact. So we are not, they're not looking for a financial return from their investment. And as the research institution, we can actually multiply that grant because we have access to human resources in the form of students, the facilities that we have, the faculty collaborations that we bring in. So we can develop, we can do the research with a focus on the function. Unlike a company where the focus would be on the bottom line, we can actually develop, do the development with a focus on the function. And then it's very important for us to interface with industry throughout the process as early on as possible. Some partner with either an established manufacturing capacity, maybe in an allied field, may not directly be in the assistive devices field. Or, we encourage our students to start up in this area and try to provide them the support for doing that. And the fourth very important pillar is the dissemination pillar, because we need to work with partners so that users are involved in every step of the development process from early on so that we understand their needs better. They are giving us feedback on a continual basis. And it will also help us once we translate the device to market, because these users will be already invested in the product because they have helped to develop it. So it's easy, we have a better chance of penetrating the market with the dissemination pillar of this grid model. And because the entire R&D is kind of funded, when we transfer the technology to the industry, the final product could be a lot more affordable than it would be otherwise if the industry had to invest in the R&D. Because typically, the R&D takes several years, and it costs quite a bit of money to come up with this. So our aim is to try to keep the end product affordable, where the industry is only trying to cover their operating costs rather than the R&D as well, R&D costs as well. So this is our model that we have applied for our, that we've been applying for our projects in order to keep the end products affordable. So as Dr. Sudhir mentioned, our first product in the market is the standing wheelchair. So you may wonder why a standing wheelchair. So standing is a very important human function, and it's something that wheelchair users cannot do very easily. And because they are in a seated position all the time, they may develop secondary problems, such as contractures, where their muscles tighten up and their joints freeze in certain positions. Or they develop life-threatening pressure sores because of being in the seated position all the time. And therefore, standing as therapy is very important for a person who is using a wheelchair. But it's also a very difficult task because somebody has to help them come up to the standing position. Maintaining them in that standing position is difficult. So although they have to do that, many of them are not able to do it, or they have to wear braces to do that. So it's a very difficult thing. But being able to stand can provide a lot of health benefits. There's plenty of research that shows the health benefits from standing. And it can also really improve their self-esteem and their functionality, because their vertical reach improves. They can do things that they were not able to do before if they're able to come up to the standing position. So our goal was to, while the idea of integrating standing into a wheelchair has been around, most of these devices are out of reach for even people in Western markets. because they are too expensive. They are customized devices, they are too expensive. And our goal was to come up with an affordable device that most people could then use for performing standing in the wheelchair. So this is just to give you a brief idea of how long it takes and the kind of effort it takes to convert an idea into a product. So from the time that we had the idea that we want to pursue a standing wheelchair, it started off as a class project, then a student project. It took some while. It was only in 2015 that we got a grant from the Wellcome Trust to work towards commercialization. And then we were able to actually assemble a full-blown team to work on this full-time. And in 2019, we were able to release the product called Arise after several iterations. So you can see here that the grid model was applied for this development. The Wellcome Trust funded the project. R2D2 did the research and testing. And Phoenix Medical Systems was the industry partner for this project. And we had extensive involvement from various NGOs like the Spinal Foundation, Amar Seva Sangam, the Association of People with Disability, individual rehab centers in various states, and individual users. So the user and rehabilitation community, CMC Vellore was one of our partners. So we had a lot of interactions with these dissemination partners that helped us develop this device. So I'll now play a video of Arise, which will give you an idea of what is possible with it. I hope you can hear the audio.
Yes, madam, we can hear.
Okay, thank you.
In 2012, I met with a road accident. Post that, we noticed my spine got a severe injury. So after surgery, I am using wheelchair. Suddenly, a fraction of a second, I lost my walking ability. So it's very hard time for me and my family as well.
Life in a wheelchair can be eventful. Day-to-day aspects of mobility demand effort and assistance, often leaving paraplegics and their caregivers overwhelmed. Hours of sitting in a wheelchair can cause secondary health problems to the user, like poor blood circulation and reduced bone density, among other issues.
Mile of injury people definitely need a physiotherapy few days in a week. So it will avoid our back sore and all. So our leg get a spasm otherwise.
However, in recent times, this 36-year-old IT professional has had a new lease of life. Ashok has been using Arise, an innovative standing wheelchair designed by IIT Madras in collaboration with Phoenix Medical Systems. What Arise does is allow a wheelchair user to stand unassisted in a safe and secure manner.
My daughter asked to take the dolls and all. No, it will be very easy for me to pick and give it to her. If you see from outside, it's very small to you, but these things are all very big for people like us.
The Arise standing wheelchair is a path-breaking, cost-effective innovation that can revolutionize mobility for paraplegics. It works on the principle of six-link mechanism combined with spring balance. This vastly reduces the effort required by a wheelchair user to stand up independently. When recommended by a medical practitioner, the Arise standing wheelchair can give a user a degree of freedom seldom experienced before. Being just a fraction of motorized wheelchairs available in the global market, the three-wheeled Arise wheelchair, priced at 15,000 rupees, stands out for another reason. It is especially outdoors ready and can easily tackle different terrains. Funded by the Wellcome Trust, the innovation has seen several iterations and trials with multiple users. Today, the Arise standing wheelchair is ready to serve users, unlocking lives as they reach for the sky.
So this was the Arise wheelchair is something that is available only by prescription, because not everybody may be able to use it, or they may need some training to use it. The assessment and fitting needs to be done properly. So it's a fully customized, it's customizable, but it needs to be done by medical professionals. So it's not something that you can just buy off the shelf and start using, which is kind of a different way to look at using a wheelchair. Because typically in India, you're either given a wheelchair, it's like a one size fits all mode of operation, and that will not work for this, because the safety aspect, not everybody may be able to stand if they have not stood for a while. For instance, they may not have the required bone density, so it requires certain assessment and checks by a medical professional. So now R2D2 is conducting, we have created an awareness video. We have created forms that a medical professional needs to use to determine the suitability of the device, to prescribe the device, and to check out the fit of the device once the user receives it. And therefore, the device cost, it's like getting, the medicine cost plus the doctor's fee. So there's a device cost and there's a treatment cost associated with using this wheelchair. So it's a different way of thinking about wheelchairs in general, that it's something that needs to be customized and to the user. So that is what, so the awareness and education is a very important part of using the standing wheelchair. And so, the awareness videos answer a lot of the questions that people may have. It's a half-an-hour video. It's available. All these resources for Arise are available on our web page. And it also has a lot of safety features to prevent accidental standing. And how should the device be customized for the user? All these questions are answered. We are also conducting workshops all over India. However, right now, because of COVID, we managed to conduct 3 workshops early this year, but everything is now, of course, stalled because of COVID. We hope to conduct many more across the country in order to train medical professionals to fit Arise properly. So one of the most moving moments for us at the launch of Arise in November 2019 was the fact that the users on stage with us, who were given Arise during the launch, were able to stand up during the national anthem. So it was, and for many of them also, it was a very emotional moment, because they had been able to do that, after a long time. Many of them for the first time after their injury. So that was really a moving moment for all of us. So Arise is the manufacturing and sales, all that is handled by the industry partner, Phoenix Medical Systems. But we are still handling the training workshops to train professionals on how to fit and prescribe the Arise standing wheelchair. Our next device that we have used the grid model, but this time with a startup that we have commercialized it, addresses this problem of indoor-outdoor mobility. So when we were doing a lot of trials and field visits for the standing wheelchair, we saw that many people have this standard one-size-fits-all wheelchair. And in many cases, it is not suitable for them, or they're not able to go very far on these devices because it's not very suitable for uneven terrain, for example, or they cannot, self-propel for many kilometers at a time. So many of them would have to either take a cab or shift to a tricycle or a tri-scooter for outdoor mobility. And as you can see, it's not the transfer process itself is rather unsafe. And these devices too may not have the support that every wheelchair user may require in order to use the device safely. So we came up with 2 devices. We decided that we could make a better, more customizable wheelchair instead of the one-size-fits-all. Give a wheelchair that has a lot of customizability for the user that fits their health condition and their lifestyle. And then we made an add-on to that wheelchair, a motorized add-on, so that they could, without transferring from the wheelchair, they could now travel outdoors by using this add-on. So I will now play a video that will explain how this works. And this is NeoMotion, which is our startup from
मेरा 2011 में दोस्त के कंधे पर से गिरने के कारण मेरा शरीर पैरालिसिस हो गया था। इस व्हीलचेयर प्रयोग करने के बाद आसानी से हम कहीं भी जा सकते हैं, आ सकते हैं। हम लगभग 1 साल से काम कर रहे हैं इस प्रोजेक्ट पे।
Of course, it's several years.
It's the best India-designed wheelchair that I've sat on in 27 years.
पहले हम व्हीलचेयर से हम जो मैराथन करते थे उसमें बहुत ज़्यादा समय लगता था। इस व्हीलचेयर के प्रयोग करने के बाद टाइमिंग है वो बहुत कम हो गया। एक गाड़ी आती है जो कि इस व्हीलचेयर में आसानी से हम सेट कर सकते हैं और गाड़ी सेट करने के बाद हम आसानी से बाहर जा सकते हैं, कम स्पेस में जा सकते हैं और कहीं भी पार्किंग कर सकते हैं और समय का बचत हो सकता है क्योंकि अगर हम ओनली व्हीलचेयर यूज करते हैं तो हमारी समय ज़्यादा लग सकता है, बट वो गाड़ी जब सेट करने के बाद आसानी से हम जा सकते हैं एक स्थान से दूसरे स्थान और जो कि उसमें पूरा स्ट्रॉन्ग है, मजबूत है, गाँव में चला सकते हैं। अगर गड्ढे ऊंचे नीचे हैं तो आसानी से चला सकते हैं। अभी हमको कोई डर नहीं है, हम कहीं भी जा सकते हैं।
See, I have a car that I drive. It's hand operated, but often the challenges that I face in terms of mobility is somebody to get your wheelchair, somebody to kind of load it, somebody to help you with the transfers. What NeoBolt does, what is the difference in terms of accessibility is, for example, going to a shop, a regular shop, what I often do is park the car somewhere. I can't get out. And if it's not nearby or if there's a traffic, then I'll have to park somewhere away, give a call to that guy. And if it's a known shop, okay, I might have the number. But otherwise, I'm just stuck. But this, I straight away go to the entrance of the shop and ask somebody to, kind of give whatever I want. Or even going to my parents' place, it's a huge challenge. My parents' place is only 5 minutes away, but I'll still have to take the car. With this, I just, roll my wheelchair out, put the bolt on, straight away go there, and then get the bolt on out, get into the lift, and go to my parents' place. So that is what it does, the ease of accessibility. I think that's the key. This makes a world of difference to us. Wherever we want to go, just bolt on and just keep moving. Be it, a flyover or a ramp, I can easily negotiate a steep ramp or even a threshold for that matter. 1 foot threshold with this wheel I can easily negotiate with, which I can't otherwise with just my wheelchair. Today when I was riding this, the feeling of the air coming and hitting on my face, I think that's the true sign of freedom and liberation. To go to the grocery shop or to the supermarket, now my wife is going to kick my backside and I have no excuses absolutely.
The third project that I'd like to present here is a prosthetic knee. So the knee performs a very important function while walking. I'm sorry, I forgot to mention that with the NeoFly and NeoBolt were also developed with the grid model. The grants here came from both government sources as well as CSR from HDFC and the Tata group of companies. Again, R2D2 was the research, conducted the research, and this time NeoMotion is the startup that came out of developing these products. So if you look at walking, the knee joint plays a very important role during walking, and it has to keep the leg stable while the foot is on the ground and the weight is being transferred over the leg. And then in another part of walking, it has to, the knee has to ensure that the leg swings forward nicely and again lands to support the weight. So the knee has sort of competing requirements. You want to be able to support the weight, as well as you want it to be able to bend so that it can clear the ground easily while walking and not make the person stumble. Now in India, what happens is, because of the uneven terrain that we encounter, the safest mode is to lock the knee joint. So people who need a knee joint either in their orthosis or their prosthesis end up having a locked knee joint, because what this does is it ensures that the knee won't buckle. It will not let them down. It will not make them fall. And so you sacrifice the functionality of the knee during the swing by locking the knee, because it's safer to do that, especially when you're walking on uneven terrain. And what this does is it leads to what we call gait compensation. So for example, you may have seen people walking with a locked knee. They have an abnormal gait where they tend to lift from the hip and then swing the leg around so that they can clear the ground. So this is also very energy intensive. So people tend to get tired easily. They cannot walk long distances. And it can also cause damage to their other joints in the long run because of this unnatural way of walking. So there are, in prosthetic knee joints, you can have either a single axis knee or you could have what's known as a polycentric knee. Single axis knees are simpler, but they have certain limitations. So either they are locked knees, or which allow you to bend it only for sitting, or some of them do allow you to bend it, but they're not very stable. So you have to have quite a bit of control over the knee. Polycentric knees are like linkage-based knees. They've been around for a long time in the West, but there hasn't been any indigenously developed polycentric knee that really addresses Indian needs. Now, I don't mean just the cost factor, because there have been attempts like the Jaipur knee, where they tried to reduce the cost of the knee by having a polycentric knee using plastics. But it's also important that the functionality of the knee is not compromised for it. And what we found was, we looked at existing polycentric knees that are available in the market, both imported and local knees. Most of them are imported knees. And we looked at the geometry to see how that affects the walking. And we found that, we identified some 6 important parameters that are necessary for walking well on uneven terrain. And we found that none of the knees meets all the requirements in the best possible manner. So we did some optimization, and we came up with what we call the Iatm polycentric knee, or the IPK. So you can see that, because these are competing requirements, it's very difficult to get a perfect hexagon. You can't, but you try to maximize, reaching the 6 arms of this in this hexagon. So that's the knee that we came up with. And this is something where we partnered with Mobility India, which is an NGO in Bangalore, for the user trials. And this was funded by Defense R&D organization called Society for Biomedical Technology. And we've designed this knee so it's made of high quality materials. It performs better on uneven terrain because of its geometry. It's actually a simpler design. It does not require an extension assist, which makes the design simpler, easier to maintain. And it's been clinically tested so far with about 20 users for a couple years now. So it's a simple, functional, and affordable knee because of its simplicity. And again, this was here we transferred the technology to Mobility India itself, and we hope to commercialize this soon. So here is a video of the Polycentric knee being used by some of the users. So you can see it can provide a pretty natural gait. It works well on different terrain. Users can negotiate ramps, they can negotiate steps. And have a more natural gait and control the knee better than with a single axis knee. It also provides greater knee flexion so that they can sit in compact spaces like auto rickshaws. For instance, in the Western countries, that's not such a big deal because you typically sit in a chair and you have enough space. So the amount of flexion that you need is not very great. But in Indian conditions, it's very necessary. So that's the difference in the way that we work. We really try to design our devices for Indian conditions and lifestyles. And the ecosystem that we have created at R2D2 is to enable this innovation so that we can innovate and make for India first and perhaps the global market as well. We've created a unique R&D environment specifically for assistive device development. We have biomechanical facilities. We have some basic manufacturing facilities. We have been creating test rigs to test wheelchairs, for instance, to ISO standards, to test prosthetic knees as well. We are now in the process of creating these facilities. And the idea is, we want more youngsters to think about assistive technologies as a career option, and we want to help them get there. And really, the journey from prototype to product to market. So it's a long journey, but we want to enable that because that is what will make an impact. And now we have realized along the way that it's not just enough to create products. The awareness creation is very important to enable independence. So it's not enough to just have an appropriate assistive device. And again, I use the example of the eyeglasses to remind people that, any of us may need an assistive device at any point. So an appropriate assistive device alone is not enough. It's important that it be affordable. It's important that there's awareness about it. People know about it and know what to ask for it, and they know how it should fit, and they know what they can do with the right assistive device. So that awareness creation also needs to happen. And of course, it's a very fragmented market. So how do you create systems that enable access to these devices? For instance, NeoMotion has now done that successfully because their entire model is done remotely. So all the fitting, so their customized wheelchair is completely, all the fitting, everything is done remotely with the user. The user sends them some measurements. They are given instructions on how to take those measurements. The fitting is done in the factory. And when the device goes to the user, it is perfectly fit to the user. All the maintenance, all the service, everything is, they empower the user to do it, and they've managed to do it, do everything remotely. So sitting in Chennai, the company has shipped to all 25 states in India over the last 1 year, despite the COVID situation. So we have to look at new models, not just in terms of devices, but also in terms of access. And only when all these components come together, only when the user has a functional device that's going to improve their quality of life, only when they are aware of it and when they can afford it and they can get one, only then is there going to be acceptance of the device. So it's very important. All these factors have to come together for greater participation of users with disability in society. So user-centric design underpins what we do at R2D2. So here are some examples of users participating in the design process or using the final devices. Once the acceptance, like I said, comes from the empowerment that comes when they have the right device that they can use. The work that we do at R2D2 would not be possible without the partnerships that we have with so many NGOs, so many medical institutions, other academic institutions, industry, and of course, the financial support that we have gotten from various organizations along the way. So these are the organizations that support our work, for the impact that we are trying to make, with a focus on that impact. So speaking of partnerships, I would like to pay tribute to a great partner that we lost just yesterday. Vedi or Vedinathan has been a cheerleader for R2D2 from the very beginning. He helped us with testing many of our products, not just himself, but because he's the co-founder of the Ganga Foundation and the Spinal Foundation, which have impacted the lives of thousands of people with spinal cord injury. He helped us connect to so many of these users that helped us to develop these great products. So my prayers for his soul to rest in peace, and we hope his guiding light continues to help us in our work as we move forward. Some of the devices that we have developed over the years are in the wheeled mobility solutions area. We have some pediatric solutions that are under development, prosthetics and orthotics, and we are now also working on rehabilitation and therapy. This is work that I'm doing with the bioengineering department at CMC Vellore, where we are working on arm rehabilitation and hand neurorehabilitation. So this is just a snapshot of the different devices that we are working on. So ultimately, our goal, is to design in India for India and make for the world. Not just make in India through with some other designs, but design specifically for India. And we hope to have more and more partners along the way on this journey. Thank you all. Please visit, that's the web address, if you want more information on any of the projects that we are working on. Thank you again for this opportunity to share our work. Thank you. I can take questions.
Thank you, madam. Now
I'll
the
stop sharing.
participants, the participants can post their questions either in the chat box, or they may also ask directly.
Hello, ma'am.
Hello.
Yeah. So first of all, really moving, projects that has been done. So I'm truly inspired, and I just wanted to know, how is your process from the, someone comes up with an idea, like maybe you can enhance on certain disability, maybe a braille keyboard for mobile or something like that. So how do you take up that process and then evaluate the market, and how do you convert that?
So the first thing that we do is to encourage people to talk to users. Is this some idea that you think will be useful for them, or is this something that they would really need? So before we proceed with any idea, we try to survey users, try to understand what their needs are, and then try to come up. So before we start working on concepts, we want to do that. So the users have to be involved, and once the users give you certain requirements, then we try to look at different concepts. Then we look at it from an engineering perspective to see what kind of design concepts we can come up with. And then again, there has to be that interaction with the users. So once you get maybe like a proof of concept, you want to again go back to the user and say, is this what you had in mind? What are some of the problems that you see there? So it has to be like a continuous process where you interact with the users to get their feedback as you are doing the engineering. So for instance, our first 3 prototypes of the standing wheelchair, most users would not be able to try it because it didn't have the necessary safety, like the chest belt and the knee block, and when actual users need to try it. So we learned about all those only during the development process, because as a person without a disability, if you're designing things, you may not really understand the problem very well. So it's very important to keep that connect with the users as you're developing it. And only when you come to a certain stage, then it's good to keep. If you have the user in mind, you will slowly start getting an idea of what is the market that you are trying to target. So that in itself gives you an idea, and then you can simultaneously look at what are the numbers that you're looking at, etc. It's a tough market because even though the need is there, the demand and the demand is not there because most people are not aware of what is possible, and also it's a very fragmented market, so that makes it quite difficult.
Yeah, thank you.
Sure. I hope that answered your question.
Yeah, pretty well.
I'm looking at the chat box.
I have a question to you.
Yes, please.
So in fact, do you have patents for this type of designs and all those things? And in what, how you are actually working once you are actually inventing these type of designs and all those things? So you will be transferring to an industry and they are actually working on it, or maybe your institution itself will be developing this type of prototypes and transferring to the particular industry. How the mode of transfer and how it is being marketed, and we would like to know those type of things.
Yes, so we do file patents for, once it comes to a certain point where we don't file patents for ideas. We file patents only when we come up to a certain level where we think that this is something that could actually be a device. Because it's surprising, but sometimes you will find patents for supposedly devices that will not even work if you actually build such a device. So we do not do that. We file patents only when we think a device is feasible. Okay, once we have proof of concept, for instance, and then in most cases we license the technology to the industry partner. So they only have to pay like a small license fee, based on every unit they sell. IIT Madras has an IP cell that handles those details. But we usually, we want to, compared to, we are actually handing, in most cases, we are handing the industry a ready product. Okay, and all we are asking is, for a license fee for that product. So we do file for patents. We do file patents for most of these. I think in our group, we have about 20 plus patents that we have filed, of which about 10 have been granted. So I think, or about, 10 or so have been granted so far, and we have another 9 or 10 pending. So we do file patents for these devices. And in some cases, like in the case of our startup, because, it was work that was done here by our students. So the company has joint ownership of the patent, but they still license it. So they still license the technology, but they do have joint ownership of the patent. Otherwise, most of the patents are owned by IIT Madras, because this is where the devices were developed. If someone else comes to us with a device they've already developed, then, it really will depend on, what stage is it in? Do they already have a patent on it? And then if we do further work, then there may be a joint ownership. It really depends on a case-to-case basis in that case.
Okay,
does it answer
thank you,
your
madam.
question? Yeah.
Yes, thank you.
Somebody had asked in the chat box about the work on pediatric patients. Yes, we are working on some things for children with cerebral palsy. We are working on a couple of devices for them. Of course, in the case of children with CP, there are very many challenges because each child is so different. So the number of accessories that they need, it's very difficult to come up with one design that is going to fulfill the requirements of all the children, plus the growth, of children. So the customizability aspects are also challenging, but we are working on, for instance, we're working on a walker that has a chair built in, so that we call it a walk chair. So it will enable the child to maybe sit in a classroom in that device, and then, during break, the child can stand up in the same device and maybe move around. Or it could also be used for therapy for various activities. We are still trying to work with our partners, therapy partners who work with such children, to sort of nail down the requirements of such a device. And another one that we are working on is again for children with cerebral palsy. We call it BMW, the body movement wheelchair, where they can move, because children with CP don't have fine motor control. They can't operate a joystick to operate even a motorized wheelchair. So we've come up with a mechanism where they can use gross body movements to move the device. So if they lean forward, the device will move forward. If they lean to the side, it will turn, etc. Some of these projects have been on the back burner for a while because, the students, it's very difficult to do product development with students. Many students may not be interested in continuing on the project. So they leave it and go. They build a prototype, they do some initial testing, and they go away. And later on, we have to, and new students don't want to work on existing projects. So when we get grants for specific projects, then we hire people to work on these existing designs to take them on that final mile. So the final mile can sometimes be the longest, taking it from a prototype to a product. That can sometimes take a few years. And that is where, we try and get funding for different projects and try to take them forward. All these projects have taken several years to be realized as products, but it's a challenge, yeah. And the first prototype is the wow factor for the students, when they see it working, but many of them may not want to continue beyond that, because that's where the details, the the detailing comes in, and that is not as exciting as seeing the first prototype work. So it's a challenge to go that to go from the prototype to the product. That's a different kind of challenge. I hope that answers your question.
Thank you. Thank you so much, madam. It was a wonderful talk. I truly enjoyed every minute of it. And I mean, I have nothing else to say than praying to God that He will give you enough, innovative ideas to carry forward your mission. Thank you so much.
Thank you so much. Thank you. There's one more question. It says, how can we increase more research infrastructure and experts in the area of rehabilitation engineering and assistive devices? I think if every university had a lab that was devoted to developing assistive devices. I mean, it's basic engineering we are using essentially with some biomechanics. And I'm sure every university can connect to NGOs in their area to try to find out what the needs are. You can develop, I would like to see R2D2s spring up in every university in the country. In more and more places. If we could multiply this model, then I'm sure we can address so many needs. First, we can start off with, students doing projects locally to address the need of one person. See, even if you're addressing the need of one person, it makes a difference to that person. So it could start, everything need not be commercialized. Everything may not have a large enough market for a sustainable business. Right? But the other idea that I've been thinking about is to have like an open innovation portal where, once you validate a design up to some extent, you publish everything that is needed about that design so that people can get it made locally and improve upon it, so that they can maintain it locally. They can, and if they have an idea of how much it would cost to build something, that would be a pretty good reference for them to get access to something that they might need. So these are ways I think that we can really make an impact in this field. I think more students getting interested in projects like this can make a whole, that is how I got into the field. I was in the final year of my BTech here at IIT Madras back in 1991. And I worked on a project with CMC Vellore and I was hooked. And I decided that, this is the area that I want to work in. And I know that some of my students, like the ones who are doing the startups, that's how they got into it. As students, they started doing projects, and once they see what an impact it makes to someone else's life, then it becomes an opportunity for them to use their engineering skills to make a difference in this field. So I hope more people take on these sort of projects. If you want access to some of the biomechanics, not everybody needs to set up a biomechanics lab, because that might, that kind of infrastructure may be difficult to replicate. But, you can maybe look at, many IITs now have such labs. So you can look at IITs in that area, or NITs, which have this kind of labs for biomechanical analysis. But you can also do assistive devices, without, not everything requires intensive biomechanical analysis. You can still solve problems, many problems, with regular design and analysis that you do. And as long as you actually involve users in the process, you can still do a lot of work in this area. But yes, our mechanical testing facilities, if somebody wants to use them, we are open to considering, how we can help you out. Any other questions? Does that answer the question of, I think that was from Jibin Jose.
Well,
Any other
Sharon,
questions?
I don't see
Yes, sir.
questions on the chat box. So
Sir,
yeah,
there are no more questions in the chat box, sir.
yeah. So well, it was a wonderful talk, Professor Sujatha. It was very
Thank you so
informative
much.
and very
I'm
useful.
sorry, it says what device is the madam using? What are the pros and cons of that? What?
Sorry, I didn't quite catch that.
Madam,
Mohammed
it
Najib?
doesn't sound.
What device is the madam using? What are the pros and cons of that?
My assistive
It doesn't
device
sound
are my
complete, madam.
glasses. My assistive device that I'm using are my glasses.
That's nice.
Yeah. And see, I need I need it to fit my prescription, right? I cannot buy any pair of glasses and use them. It's not going to help me at all if I just pick someone's. So just as one size fits all doesn't work for glasses, it doesn't work for other assistive devices also. So that's why, we need to be sensitive to that while designing and not assume that a wheelchair is just a chair with wheels. It doesn't work that way. Yeah.
There is a request from Mr. Rakhu. He is the director of R&D institution which concentrates on development of products to reach the market. He wanted to have your email ID. I think
Sure.
Professor Sujatha's email
I'll just,
ID is anyway on the website of IIT Madras.
Yes, it is there. I'm also typing my email in the chat box. So you can also contact r2d2outreach@gmail.com because sometimes, so I now have a person who handles outreach and partnerships and collaborations for R2D2. And it's very, you saw him in the video, in the NeoMotion video. He's the person using the NeoBolt. So he is, he has been a wheelchair user for about 9 years or so. So he brings an extensive lived experience as a wheelchair user. And he's also, he has extensive corporate experience as well. And he now heads the Spinal Foundation. His name is Justin Jesudas. He's also a Paralympic athlete. He's a shooter and a swimmer in the Paralympics. So he handles outreach for us at R2D2. So you can reach out at that email and he'll be happy to take it forward. Because sometimes, in the deluge of emails that I get, I might miss out. So please do reach out to Justin. I'll just write his name, Justin Jesudas. So you can reach out to him at r2d2outreach@gmail.com.
Yeah. So Sharon, we can propose the vote of thanks and wind up now. Yeah.
Okay, sir. Good evening, all. I'm extremely happy and very privileged to propose the vote of thanks today to Professor Sujatha Sreenivasan, who's a top technocrat in the country and who's contributing her expertise to develop affordable and assistive devices suited for the Indian conditions to the lesser privileged population. So she definitely is a person who can steer and encourage our engineers to contribute their engineering skills for the betterment of the society. Thank you, madam. On behalf of KSCSTE and the APJ Abdul Kalam Technological University, I extend my sincere gratitude to you, madam, for accepting our invitation and also for sparing your valuable time for delivering a talk on a very important topic. Thank you, madam. Thank you very much.
Thank you very much. Thank you. It was my pleasure. Thank you for the opportunity.
Thank you, madam. I also thank all the participants, the engineering students, the researchers for being with us today also. I thank all the officials from the APJ Abdul Kalam Technological University, directors of R&D centers under KSCSTE, my senior scientists at KSCSTE, colleagues for being with us and extending all the support needed to organizing the program. Thank you all. Thank you once again. The next webinar will be on 17th May, Monday at 4 p.m. The speaker is Professor Krishna Kumar from IIT Madras, delivering a lecture on the topic, on a very interesting topic, human heart, an engineer's delight and a doctor's nightmare. I repeat, human heart, an engineer's delight and a doctor's nightmare. Professor Krishna Kumar is a person who brings out the marvel of engineering within the human body. So I hope we can all meet on 17th May at 4 p.m. and listen to his wonderful lecture. So meet you all on 17th May and wish you all a very safe weekend. Thank you.
Thank you.
Thank you very much. Thank you. Bye.
Bye, madam.